Hi, welcome to Math with Mrs. Leslie. In this video, we are going to discuss volume of three-dimensional figures. We're going to start with some basic three-dimensional figures as cylinders and rectangular prisms, and work our way into triangular prisms, and also into figures that are composed of multiple types of three-dimensional figures. You'll see that we jump around a little bit. I may not end up doing all of the problems on here. For those of you in my class, you will see that these problems do look familiar. They're from our volume of three-dimensional figures review worksheet. And so if you had any problems with that after we discuss it, you could even go back to that specific worksheet and watch how some of the problems were solved previous to our quiz. So looking first at problem number 1, we recognize that that is a cylinder. And the formula for finding the volume of a cylinder is 3.14 times the radius squared times the height. Now, in this case, we need to locate the radius and the height. First thing I notice when I look at the cylinder is that I'm not given the radius, I am given the diameter. I'm giving the entire distance from one end of that circular base to the other. And the height, I am given. So in this case, I'll end up plugging in what I know, 3.14. When it comes to the radius, I know that the radius is half of the diameter. So in this case, the radius is 5. So 5 squared times the height, which is 8. At this point, when I do this calculation, you should end up with 628 and meters cubed. Remember, volume is describing a three-dimensional space, and so it is meters cubed for our units of measurement. The second figure is actually a rectangular prism, one of the easier formulas to deal with because it's just length times width times height. Technically, it does not make a difference what order you multiply it in, whether you multiply the length times the width times the height, or the height times the width times the length. Again, doesn't make any difference. So in this case, we could do something like 11 times 8 times 16, and in that case, 1,408 centimeters cubed. The next one, number 3, and I'm running through fairly quickly, so you can pause this video at any time or rewind it, which is the beauty of watching the video. But the third one is actually also a cylinder, just like 1. But the nice thing about 3, as compared to number 1, is they give you the radius. So for this one, it's just a matter of plugging in. So for this one, the formula is 3.14 times the radius squared times the height. But now I literally just plug in. I see the radius is 28, I square it, I see the height is 60, and when I plug in and I get my answer, it is 147,705.6 inches. And just so you are aware, all of our measurements will be rounded to the nearest tenth. So if I ever put something up here and you say, no, I got something different, I got a longer decimal, I will be rounding everything automatically to the nearest tenth where it's necessary. Okay, so if we were to move on, we see 2 more figures here. The first one's a pyramid, specifically a square pyramid because the base is a square. So the formula here that we would use is 1/3 length times width times height. The length and the width will be the 2/18 because at that point for the base, the length and the width of the base, they are the same because it's a square. And then the height of the entire figure, which is what that height stands for, is 60. And so now that I've plugged in, if I was to do my calculations, 1,728 inches. This next one's a cone, and again, I'm running through fairly quickly. You do have a formula sheet, so you can always cross-reference your formula sheet, but the formula for the cone is 1/3 times 3.14 times the radius squared times the height, and again, it's a matter of plugging in. They give us the radius, they give us the height. If anything, the only thing I would say to you is watch for if they gave you the cone and they gave you the diameter, similar to what we saw with the cylinder. anytime you're using the radius in a formula, you want to make sure you absolutely plug in the radius. So if they give you the diameter, you've got that extra step of dividing it by 2 first. We don't have that here, so we can plug in. And if I was to do this calculation, what I would expect you to see is 1,271.7 inches cubed as a final answer rounded to the nearest tenth. The next two that we're going to focus on, specifically 10 and 11 here, or what's labeled as 10 and 11, and these problems do not go in any particular ordering of numbering, so just be aware of that. The numbers have been adjusted. If you're working off of a worksheet that I've given you in class, the numbers were adjusted for the worksheet, but just as a reference here, I'm not going to worry about the cylinder, which is labeled on here number 12. I'm just going to focus in on 10 and 11. Now 10 and 11 look different, but they actually are both triangular prisms. Okay, they both have triangular bases on the ends, and then rectangular pieces that go around them to connect the two triangles. And so for both of these, we will be using the formula 1/2 times base times height, which is the area of the triangle, times the height of the entire figure. So I'll say that again. In parentheses there, that 1/2 times base times height is specifically the area of the triangle. One of them, it doesn't matter which one, okay? Then, the height of the entire figure connects the two triangles. So in this first problem, number 10 on the left, the base and the height of the triangle create the 90-degree angle here that I'm tracing. And so it's 1/2 times 11 times 12. And again, that's only focusing in on that triangle. I'm going to switch colors here just real quick so you can see that this height, the second one, actually comes from the connection between the two triangular bases that are opposite each other. And so that is 11. The heights can be equal of the entire figure and the base, but it doesn't have to. That would be sheer coincidence. And so if you were to actually do this calculation, if you found the answer to this, it would be 726 inches. To do one more triangular prism, which is number 11 here, again, I use the same formula. So I'm going to kind of slide this over. Use the same formula. But in this case, there's some extra information. The base and the height create a 90-degree angle. So what I'm here of that triangle. So that's telling me that the 1/2 times base times height has to equal the 5 and the 12 for that triangle. Then, if I was to look for the height of the entire figure, what I had in green in the last problem, that's the connection of the two triangles that are opposite each other. So that's the 16 here. Technically, that 13 is extra information. It's not necessary for volume, so we just leave it as is. And then the answer to this one would be 480. And it's feet cubed. And always make sure you get your label. Next, what we're going to go into is a quick word problem, and then we'll deal with some figures that actually have more than one figure within it. So figures that are composed of multiple three-dimensional figures that have to be split apart and then found the volume of the entire figure. So this next problem, it says, what is the height of a rectangular prism if the volume is 385 inches cubed? The length is 5 inches and the width is 7 inches. Well, in this case, we want to set up a formula or an equation that will help us solve for that missing height. I know that for a rectangular prism, to get the volume, it's length times width times height, and that gives me the volume. So let's plug in what we know. We know the length is 5, we know the width is 7. We do not know the height, so I'll leave the h. But we do know the volume. So really what I know is that 5 times 7 times some number of h has to give me 385. But I know that this 5 times 7 is 35. So technically, 35 times h has to give me 385. Well, if that's the case, then I just need to do the opposite of the multiplication to find what my piece for h would be. And so I'm going to divide 385 and both sides by 35. That's gone, and so h equals 11 inches. The idea of any type of problem where you're working backwards to find something that's missing, like the length or the width or the height of a figure, but you're given the volume, the idea is first set up that equation, plug in what you know, and then work through the problem. So many people try to work through the problem before they have a plan. And they say, oh, I'm going to divide, and then they get lost in their steps, and they don't realize what they've missed, or maybe what they've done more than once. So setting up the equation, plugging in the information you know, then solving for the unknown is exactly the process you should take in a word problem like this where you're working backwards. That is actually the same thing. And so our next problem is going to be this one. So now if we look at this figure, we see we have really a quite odd looking figure. It's not exactly one of the figures that we have a formula for, but if you look closely enough, you will notice that this is actually just a cube with a pyramid on top, specifically a square pyramid if we were going to get specific. So when we notice that, you can notice that we can get the cubes, get the cubes formula using your same rectangular prism formula, length times width times height. We will notice that it is just equal. So for the cube, 12 times 12 times 12. You could also write this as 12 to the third power. And in that case, the volume is 1,728. And that's centimeters cubed. If you look at now the pyramid, the formula here would be 1/3 length times width times height. And in that case, your length and your width are actually going to be 12. We'll look at the bottom cube, we can see that opposite here and here is 12, and here is 12, so this also has to be 12 here. And so we see the height is 18, so times 12 times 12 times 18, and in this case you should get 864. Again, being centimeters cubed, and we'll add our label to our final answer. So if we take these two volumes, now that we've split this figure up, we found the volume of each one. If we put it back together and we add these two volumes, we'll have the volume of this entire figure. And so we add these two, and we get 2,592 centimeters cubed. Let's try another one. So in this next one, you see now a rectangular prism with a cylinder on top. So we just need to work with both of the formulas for each of those separately, add them together. So now our rectangular prism, length times width times height, so 14 times 8 times 12, that will give us 1,344. And then our cylinder formula is just 3.14 times the radius squared times the height. We can see when we look at it that we are given the radius, which is 4, we are given the height as 8, and so it's just a matter of plugging in. And in that case, if I was to solve that, I should end up with 401.92. Even if your directions say to round, you should not round to the end, because sometimes if you round too soon, it can affect your answer. And so in this case, we'll add them together, and I'll round also, so when it's added together and rounded, 1,745.9, and the label here, feet cubed. The last one. We have two cones, both of different sizes, so we're going to deal with both of them separately, and then we'll add them together. The cone formula is 1/3. I'll write this once right here, 3.14 multiplied by it. Erase that, ran together. So 3.14 times the radius squared times the height. So now dealing with this first one, 1/3 times 3.14. The radius is 6, so I'll remember to square that, and the height of that cone is 8. If I was to calculate that, I should expect to see 301.44. For the second one, we'll extend our arrow here. It's 1/3 times 3.14 times the radius, which is given to us is 10. Square that and multiply by 24. When we solve there, we get 2,512. We'll take these two, add them together to get the volume of the entire figure at 2,813.4. And that is rounded, and it's meters cubed. So really, it's a matter of using your formulas carefully, plugging in the information appropriately. Watch for situations that have radius, and you may be given a diameter. Watch for situations where you have multiple figures that form one big figure, like this, where you have to find them separately and then add them together. All in all, it's a matter of using the appropriate formulas, the appropriate information within the formulas, and you should get the right answer. Feel free to rewind this and redo problems to review for any, quizzes you have coming up, as well as feel free to go back through the video, re-look at a problem, pause it, solve it, and then start the video back up, and you can see how you're doing and if you're following along that way as well.